Linear regression is one of the most popular tools you're going to come across and use in your career as a process improvement professional. And let's have a look at that now. What we want to do is label, beginning with the tool, we want to label the X, the data, and so perhaps this is temperature or something along that nature. Maybe this is time, something like that. And then we're gonna lay our data in. Don't put any values here in these cells. Remember, in these templates, it's only the yellow cells that require the data. So this just happens to be a summary of what's down below here. So lay in your data here. Once you have your data laid in and your X is labeled and your Y is labeled, you can see that they translate here onto the graphic. Next thing we do is select a confidence level. So in this case, we're going to select a 95% confidence level. And then the template will generate the regression model and or the regression equation. And so here it is, and what it says is the time it takes is equal to 204,486 0.843 plus 4,031.443 times whatever the temperature is that you're using. And in this particular example, there's an R-squared value of 0.81 and an adjusted value of 0.8124. So that's quite high and quite good. And what it's saying is approximately 81% of the time is predicted by the temperature, and the other 19 or so percent that is unaccounted for in the model is due to other factors over and above time. Then what we can do is we can come down here and actually play then with the model. We could put a temperature in here, let's say it's 500 degrees Kelvin, and that will give us a predicted temperature, a predicted time of 2.2 million. And also given here is the prediction interval. So on the lower end of the prediction interval it's 1.6 million, and on the upper it's 2.7 million. And similarly we could do it sort of reverse, as it were. So we could pick a value of say 3 million, and the temperature would be 693 with no prediction interval. The prediction interval, by the way, that's different from the confidence interval, but the prediction interval is the interval for this specific example that we're using, for this specific data point, test point. And you've got a graphic here, and you can see based on the data that there is quite a strong relationship. As I increase my temperature, I do tend to increase my time as well, and then that red line is sort of a best fit line between the data points. So that's it for regression. Again, it's a very good tool. Oh, one thing I do want to mention before I end the video, and that is be careful of the inference space. And the inference space here is temperatures of somewhere. We'd have to look down here in the temperature range. What I'm looking for is the range, but it looks like it's maybe 37 is the lowest temperature, and somewhere in the 550 range is the maximum temperature. And these models are good for inferences and prediction between those two extremes of temperature, but be very careful when you try and extrapolate out here beyond the inference space, which is the range of the temperature data. And that's it for regression.